Hi, my friend. I hope you are doing fine. Welcome to Joey's Tech. In this video of Joey's Tech, I am going to focus on another lead code problem, which is the house robber problem. Now, this problem is different from the 01 knapsack problem, so don't confuse it with that. It's a little bit tricky, but a lot of fun to solve, and I'm sure that you are going to enjoy learning it. So, let's begin the game and see its problem statement. So, a professional robber is roaming in a neighborhood. Now, the robber is looking forward to steal from certain houses along a street. The houses are deserted because the inhabitants of those houses have gone out to see a movie. Now, each house of that street has got certain cash stashed in them, which the robber can steal. There is one condition that spices up this problem, which is the robber cannot steal from two adjacent houses. If he does so, this is going to trigger an alarm, and this alarm is going to call the police. So if two houses are in a series, then the robber cannot steal from both the houses, because doing so will call the police. Now your job is simple. Your job is to find out the maximum cash that the robber can steal from the houses without calling the police, without alerting the police, without triggering the alarm. So here is an array that gives the cash stashed in each of the houses, and the cash is represented by non-negative integers. So 2 is the cash in house number 1, 7 is the cash in house number 2, 9 is the cash in house number 3, 3 in house number 4, 1 in house number 5. Now, if the robber steals from house number 1, then he cannot steal from house number 2. If the robber steals from house number 1, then yes, he can steal from house number 3. So the total cash stolen in this case will be 11 only. In this example, that means I am talking about these three houses only. We are going to move to our framework now, where we are going to construct the dynamic programming algorithm of the house robber problem. But before we do that, if you haven't subscribed to my channel already, then do hit the subscribe button and the bell icon next to it, because that way you will get notified whenever I release videos like this in future. Now let's quickly switch to the framework and begin solving this problem. Alright, here is our problem array, which represents the cash stashed in each of the houses. Now, when I first encountered this problem, I thought of solving it using the classic longest increasing subsequence approach, using two variables. And let me tell you, it worked pretty fine in my favor. But then I found out that there is an optimized method to solve this problem as well. So in this video, I am going to tell you both the methods. I am going to explain this problem to you using both the methods. So the first array is the solution array for method 1, and the second array is the solution array for method 2. We will start filling it from the first cell, and we'll move all the way to the last cell. The last cell over here is going to give us our answer. Now, the difference between method 1 and method 2 is that when I solve this problem using method 1, the time complexity will be O(n) square. But when I solve it using method 2, the time complexity reduces to O(n). So I think if you learned both the methods, it would be better for you. And it will also help your skills needed to solve such problems. So let's begin solving this problem using method 1. So I put J over here and I over here for every iteration of I. J is going to go back to its base position first of all, and then we'll start moving towards I. Based on the condition given in the problem, we are going to calculate the value of the cell represented by I at that moment. Now, I am going to populate the first cell of the solution array with the first cell, with the value of the first cell of the problem array, which is 2. So this is our base case. This also means that when there is only one house and other houses do not exist, then the robber can only take the cash as 2. Alright, there is nothing more to steal. Okay, So now we are going to calculate the value of this particular cell. So only we have this cell under consideration, and we have the cash which is there in house number 2. Now, can the robber steal from this house, house number 1, which currently is represented by this array, the total cash, and from house number 2? No, he cannot, because they are next to each other. They are adjacent. So, all the algorithm will do is find out the maximum value between this value and this value. So what is the maximum value? It is 7. So 7 will be populated in this particular cell. Now I moves one cell to the right. Okay, so J is at its base position only. Now when the robber is stealing from house number 3, could he have stolen from house number 1? Yes, he could have, because they are not next to each other. So this 2 will be added to this 9, and I am going to get the value as 11. Why I have written the value here? Because a comparison will be made to pick out the maximum value between this value and this value. Alright, because this is the maximum value that I have got till the previous house. Alright, and the robber cannot steal from these two houses. So we will have to pick the maximum value. Now between 11 and 7, which is maximum, 11. So 11 gets populated over here. Now I moves one cell to the right. Okay, so the robber is at house number 4. Could he have stolen from house number 1? Yes, he could have. So 2 plus 3 is going to give me 5. That is my first contender. Okay. Now J moves one cell to the right. Over here. Okay. So when he is stealing from house number 4, could he have stolen from house number 2? Yes, he could have. Here the value is 7. So 7 plus 3 is going to give me 10. So let me write that value over here. Now J comes over here. So when the robber is stealing from house number 4, could he have stolen from house number 3? No, because they are adjacent, they are next to each other. So all we are going to do is compare all these values to pick out the maximum value. 11 here is the maximum value, so 11 will be populated over here, and other contenders will be eliminated. Cool. Now J goes back to its base position. I goes one cell to the right. Now when the robber is stealing from house number 5, could he have stolen from house number 1? Yes. So 2 plus 1 is going to give me 3 as one of the contenders. Then J moves one cell to the right. Okay, so we have 7 over here. Alright, so 7 plus 1, because I and J are not next to each other. So 7 plus 1 is going to give me 8. This is also one of my contenders, 8. Now J moves one cell to the right. Okay, so I and J again are not next to each other. That means the houses are not adjacent to each other. So 11 plus 1 is going to give me 12, again one of my contenders. J moves one cell to the right. Okay, now J and I are next to each other. So 11 cannot be added to this and cannot become one of the contenders. What will happen? There will be a maximum value selection between these 4 contenders. 12 is the maximum value and it is already at the right place, so other contenders will be eliminated. And 12 gets populated in the last cell, and 12 is our answer. So 12 is the maximum cash that the robber can steal without triggering an alarm in this scenario. So this is method number 1. Now method 2. The fun about method 2 is in realizing that the last 2 cells of a cell for which we are calculating the value will always hold the maximum cash till the house in which the robber is right now. We cannot add the value stored in the immediately previous cell to the cash which the robber is stealing in the current house, because they are next to each other. but we can add the value stored in the cell previous to the immediately previous cell to the cache which the robber is stealing right now. So we'll be having two contenders. One will be the value of the immediately previous cell, and the other will be the result of the addition of the value of the cell previous to the immediately previous cell and the current cache stolen by the robber. We'll pick out the maximum and populate the value of the current cell. Now I am going to show it by doing it here, but let me first populate the base cases. So I'm going to populate 2 over here. This is my first cell. Now since we are talking about the last two cells related to a cell for which we will be calculating the value, hence I'll have to populate cell number 1 as well. This will be the maximum of these two values, which is 7. Alright. So let me populate 7 over here. This also means that had this been greater than this value, then this value is getting pushed forward to second cell, because we believe in storing the maximum values for the last two cells. This also means that had this value been greater than this value, then we would have pushed it forward, because the maximum value is getting pushed forward in our solution array. Now we'll start solving the problem from here. Here the cache in house is 9. So the robber is currently here. So the robber has two choices. The algorithm has two choices. One is add 2 to 9, which will give us the value 11. And the second choice we have is 7. So 7 and 11 when compared is going to give us 11. So 11 gets populated over here. Okay. Now I moves one cell to the right. Here we have two choices. One is 7 added to 3 is going to give us 10. And our second contender is 11. So we need to pick out the maximum value, which is 11. So 10 gets eliminated and 11 gets populated over here. Notice how I am referring to just last two cells. Alright, we don't have to go to any of the previous cells now, other than the last two cells. Now I moves one cell to the right. Over here we have two choices. One is 11 plus 1, which is going to give me 12, my first contender, and then I have 11 as my second contender. So the maximum value out of these two is 12. So I am going to populate this cell with 12, and this is my answer. So this was method number 2. Now we are going to take a look at the algorithm of method number 2. So the first cell represented by index 0 of the solution array is populated with the value of the first cell of the cache in house array represented by index 0. Then the cell represented by index 1 of the solution array is populated with the maximum value out of the first two cells of the cache in house array. The loop starts from the third cell and goes all the way till the last cell. And this over here is the operation which I explained to you in method number 2. The time complexity of method number 2 is On, as I explained to you earlier. So with this, we have come to the end of this video. I hope you enjoyed watching this video. I hope you learned from this video. Do give it a thumbs up. I look so much forward to help you with programming and algorithms only for this video. Goodbye and take care.